It clearly shows that your passion for teaching and learning and contributing. You also have a passion about open educational resources and open knowledge products, which I think are important in structural engineering, especially today as well. How can these tools help bridge the global gaps in access, especially in maybe underserved regions of the world?
Academics can work and develop open resources around several open source programs, tools, and technologies. So, not only can ensure equity and also ensure equal access to knowledge resources, we can exploit uh, that potential in open resource platforms or tools to enhance experiential learning as well.
What if the biggest barrier to engineering innovation isn't technology, but access to knowledge? While structural engineering tools and software have advanced rapidly, educational resources haven't kept up, especially for students and professionals in undeserved regions. The result? A growing gap that holds back creativity, equity, and progress. In this episode, I'll be talking with Dr. Fawad Ahmed Najam, lecturer at the University of British Columbia, and a leading advocate for open educational resources about the future of structural engineering education, and more specifically about how digital tools, foundational courses, and AI are transforming the way students learn and how educators can adapt. If you've ever questioned how we learn, what we teach, or how to future-proof the next generation of engineers, this episode is for you. I'm your host, Matt Picardle, and this is the Structural Engineering Channel. Dr. Najam, thanks so much for joining us. To start things off, can you tell us a little bit about yourself and your career in structural engineering and what brought you to your current role at the University of British Columbia?
Yes, thank you, Matt, for having me. And I'm really happy to talk to you and also get connected to your audience. I was born and raised in Pakistan, where I had basic education, my undergraduate degree, and master's degree in civil and structural engineering. I always used to like math and physics and decided to pursue engineering as my career. My decision to pursue structural and earthquake engineering was mainly led by my experiences during and after an earthquake event in Pakistan. In 2005, we call it Kashmir earthquake. It was a magnitude 7.6 earthquake event and caused massive destruction in northern part of the country. So, being an first year undergraduate student at that time, I volunteered for several social work and related activities. And that whole experience led me to be curious about the issues around structural safety and how the buildings behave and perform under different types of excitations and loadings. So, that curiosity led me finally and naturally evolved into a passion by the time I finished my undergraduate, and then which led me to decide towards starting a career in faculty. I also realized that I how much I love uh, helping others in explaining ideas. So I joined Asian Institute of Technology in Thailand for a PhD program. And then after that, I came back to Pakistan and joined the National University of Sciences and Technology as a faculty member. So, in my 4 year career there, uh, I established a research group in the area of earthquake engineering and contributed to my own passion as well, which was teaching and learning. I also was the committee member in the National Task Force, which led to the development of the updated National Building Code of Pakistan, worked in several national committees to develop standards for several seismic safety issues and related areas. So everything was going fine, but I also wanted to contribute at international level. I always wanted to do more and also wanted to pursue my passion for teaching and learning in a more competitive environment. So one fine day, I saw a postdoc position at University of British Columbia, and its description was matching with my own experiences in research. So I applied for that, got that position. And after coming here in 2023, during my first year of that postdoc work, I found this lecturer position, which was matching with my past experiences and my own curiosity in that particular domain. So I all my past experience as well as my passion for contributing something new uh, helped me in getting that position and starting my career as a lecturer here in the School of Engineering. So since last year, I in this role I am teaching courses related to earthquake engineering, seismic analysis, and I am also involved in teaching foundational level mechanics and dynamics courses to first year engineering students. So this was my quick summary or my story of how I end up being at UBC from that part of the world.
Yeah, that's awesome. Yeah, I know it's a similar story. I think with at least people with that grew up with earthquakes. I knew that's how I learned about structural engineers when earthquakes hit, and you would see devastation throughout some countries, and then some countries not as much. And then you learn about structural. I learned about structural engineers from that. I was like, oh yeah, buildings don't have to fall down all the time. There's engineering behind them,
Yeah.
and it clearly shows that your passion for teaching and learning and contributing. You also have a passion about open educational resources and open knowledge products, which I think are important in structural engineering, especially today as well. How could these tools help bridge the global gaps in access, especially in maybe underserved regions of the world?
Yeah, I'm a strong supporter of open educational resources and open knowledge products. And I also always tell my students the importance of having these resources and developing these resources. There is a personal aspect of that part of passion towards OERs or open educational resource movement. During my PhD and after that, I co authored a book named Structural Cross Sections Analysis and Design. And that book was published right at that time when I finished my PhD. And when I came back to Pakistan and started using that book as a textbook, I realized that many of my students were not able to purchase that book. And I realized that in several parts of the world, students don't have access to costly textbooks, or they may not be able to seek mentorship. They may not have access to costly design and analysis software. So when I realized that I spent many years in authoring a textbook which my students are not able to purchase, that was the turning point where I started my YouTube channel, Understanding Structures with Fawad Najam, and I started sharing my lectures and online educational resources on continuous basis for free. I also started my own website where I start uploading my lecture material and handouts and all those training materials I have been using and developing over last many years. Both of these resources got a very good response among students as well as the engineering community, and they have grown to tremendously in last 3 or 4 years. And at the time when we are talking at this stage, I receive almost daily many emails from students from various parts of the world thanking me to upload those materials. Those resources helped several students to complete their research goals, to complete their thesis objectives, and so on. So those emails and messages which I receive on almost daily basis uh, keep on reminding me that we need to go into that area and pursue that area of developing OER with full energy, with full passion. This is, I feel, is kind of becoming a global responsibility for all academics to contribute. So this is my personal story why I started in this contributing to this particular area. But beside that, I also feel that currently we are living in a generation where students always follow click to learn approach. So they want interactive visualizations. They are heavily dependent on software demonstrations to develop their intuition about structural behavior. So all those latest tools which we are going to test and apply to our learning and educational experience. I think there is a huge gap or a huge area where academics can work and develop open resources around several open source programs, tools, and technologies. So not only can ensure equity and also ensure equal access to knowledge resources, we can exploit uh, that potential in open resource platforms or tools to enhance experiential learning as well.
Yeah, I know I was telling you earlier too, even before you were on the podcast, that I was using your resources to catch up on some performance-based design items that I just wanted to do some self-learning for work as well. And yeah, it's a great resource. And you don't really find that. Yep, I remember I had to go back to my master's classes to do some notes. But since there was so little information about some of the more advanced earthquake engineering items, but I know your website, your YouTube channel has that. And as a professional, that's a great resource, and it was refreshing to see that and the quality of work that you put out there. And I think that's great because I think at least in the US, in order for maybe students that want to learn those types of things, they might have to get their master's, or maybe in their master's program they didn't teach those important subjects. But it's all in there if they in case they want to learn or they have to learn on the job as well. So I think that's great just because there's as engineers, there's already a lot of stuff that has to pay for, even the books, codes. So anything that can help us just learn and become better engineers, I think that's great what you're doing.
Yeah.
And how's the structural analysis software transforming the way students learn? I know nowadays there's a lot more emphasis on the software. I guess what have you seen with the structural concepts, and how can educators balance, instead of just students just learning the software, how can we balance that with the theoretical concepts to make sure that engineers know what they're doing?
Yeah, this is an interesting question. There is a notion in academia that the use of latest computational platforms, the computer aided design software, and similar tools are somehow opposing or somehow adversely affecting the critical thinking and the foundational concepts, the theoretical built up, and all those related concepts among students. While I don't fully disagree with that notion, but I feel that we academia can more effectively use these tools to actually enhance the learning experience and actually can build upon the theoretical concepts and critical thinking of students. I feel that structural engineering programs are not being used more effectively or efficiently in the current curriculum in several parts of the world. They are still being used as black boxes and still being used to just validate the manual calculations. Instead, I feel that if we teach students about how these programs actually work, we can actually develop critical thinking skills by using these programs and using these programs as like lab bench, do different experiments to computer models to demonstrate them what happens if we, for example, change support conditions, or if we change any input parameters to see how it affects the overall structural behavior. So I feel that instead of limiting their use in several curriculum courses or any other specific domains, what we can do is we can change our mindset to use them more effectively, to devise small experiments to contribute to students' understanding about structural behavior. So there is a huge potential in that area, but somehow I feel that the technology integration in civil engineering curriculum needs several changes, especially in second or third year analysis related courses, where There are instructors who love to have them, these programs on one side, for example, the use of SAP 2000 or ETABS in solving indeterminate frames and so on. But on the other side, there are instructors who are not in favor of using these programs because they think that it is kind of having an adverse effect on the critical thinking abilities among students or their theoretical concepts. So I agree with the idea that there should be a healthy balance between them, but I would also like to emphasize that the way we currently are integrating these software tools or computer aided design programs in curriculum needs significant improvements. Instead of using them as black boxes, we may uh, need modifications in curriculum to include uh, procedures which these programs are using or implementing to produce analysis results so that students can directly connect their theoretical concepts, their knowledge with the outputs of these programs. So I agree that that balance needs to be accomplished, and I think academics need to take a lead in that.
Yeah, I think that's the black box concept. As personally for me, like training new engineers, that's something that it's an easy trap for new engineers to
Exactly. Yeah.
get trapped in. And yeah, I've always found it to what you were emphasizing, the behavior of the structure. I think that's a good thing for what these tools can do. It's not just, hey, we already know the deflection of a beam, prove it this with the SAP software. That's not really telling us anything. It's just kind of showing us what we already know. But how can we use it to further our understanding of behaviors of structures, but also knowing the limitations of of it, like what type of equations or what type of methods are these softwares actually using, which you may end up finding some weird results, and it might be have something to do with the way the computers are running those equations. So I think
Exactly.
there's definitely that balance that you were saying.
Yeah. And the point about structural behavior and its understanding is really the key. I mean, this has always been the core idea in all my teaching structural engineering courses, that the students should think always in terms of what is happening to structure and what is its behavior after running the analysis. That is the core part, that interpretation of structural behavior. It actually reminds me of an interesting story which once my PhD advisor shared with me. He told me that he was once visiting an industrial steel building for a specific health assessment project, and he saw that there were actual hinge supports and actual roller supports in that structure. So he asked me that, have you ever seen a real hinge support or a roller support uh, in real structures? And I replied that uh, these are all structural idealizations, and the actual connections between different steel elements are always somewhere in between these ideal support conditions. But he told me that no, I saw the actual hinge support and an actual roller support in a steel building during one of my visits in an industrial building. And he said that I asked those engineers why you designed those supports as an actual hinge and an actual roller. And their reply was that we wanted to have confidence on our calculations. Uh, we wanted to construct our structure the way we modeled or idealized it at the stage of structural analysis. So we wanted to have that confidence on shear forces and bending moments and reaction support reactions in all the members. So they preferred a confidence on structural behavior over some sense of redundancy or having some unknown amount of safety. Because of that, they preferred structural behavior and its understanding over that. So I would say that if your decisions are led by the romance of understanding structural behavior, then you would know that you are a structural engineer by heart.
Yeah, it seems like I think that's I'm looking back at the way I've mentored students, and it's always coming back to what do you think the structure is going to do if you do this? Or what happens if you do this? Or if you move this beam here and you make it a cantilever, do you think deflection is going to govern shear, moments, or even in earthquakes, what the mode shapes are? I think it always comes back to that. Like it goes back to structural behavior. I think that's what's really important nowadays. Maybe not as important if you don't know how to derive these equations, sure, but you shouldn't be knowing if you do something, how is the structure going to behave, elastic, inelastic, things like that. Going back to the fundamentals of mechanics. Yeah, I think that's a great fundamental to get back on. I think nowadays too, with all the software can do those analysis and those calcs, but the engineers should be knowing how it's going to behave, at least a sense of it, or else, yeah, it's a black box.
Exactly.
And with all the advances in technologies, with software, AI, and automation, how do you see these tools shaping the future of structural engineering and education?
Yeah, AI is a hot topic nowadays. Like educators like me all around the world are trying to find innovative ways to integrate this technology in their teaching and learning. Uh, First of all, I would say that we should not think of AI as just one tool among several other tools available to us in our toolkit. It's a completely mind shift activity to use AI in teaching and learning. You have to change your way of thinking about teaching to effectively use this new tool. With that, I would also mention that there is a strong aspect of kind of social dimension associated with cognitive learning. I mean, there are some types of learnings which can completely be called as a social activity, but to say the least, cognitive learning have a strong social dimension. So this is something which uh, gives us a whole new area to exploit the potentials of AI. So the access to educational resources uh, has never been an issue in recent years. So we have a lot of new resources coming in, and with advent of several new tools for learning and open resource software, that area was already benefiting from those developments. Where the real potential of AI, I think, would be in kind of enriching the social aspect of learning. So we should use it in our classrooms. We should use it in live demonstrations. We should use it in our lab environment and all those areas of teaching and learning where social activity is involved. So that is where the real potential is, because accessing educational resources was already being covered by by YouTube or by all other resources, internet resources available. So this is one area, the social aspect of learning domain, where AI can be more effectively used, and I'm still thinking of how we can effectively use it. But one thing is clear: this is the age of asking right questions. So you're asking about the future of structural engineering and how it may impact the profession as a whole. I feel that it depends a lot on whether we remain successful in training our next generation of engineers in asking right questions, because that holds the key to effective use of AI. So there have been never so this is a time where the importance of asking right questions becomes even more important, and we need to unlock this potential. But still, there is a lot to understand. There is a lot to deal with in this kind of bombardment to us with technology and latest tools coming to us on almost daily basis. So so academics need to develop their skills as well, while our learners are also trying innovative ways to exploit the potentials of these new technologies.
Yeah, I know with AI, it's definitely it came quick, and now educators need to adapt to, especially I've just been hearing teachers like, yeah, the kids will do homework. It's you have to adapt in terms of it's a new tool. How are we going to use that to not just straight out ban it? How do we use it as a tool? And and like you were saying, how do we ask it the right questions? Because I think AI is that's a big thing with AI, at least with the ones that you ask for prompts. Like how the power is in the questions on what you ask it. And I always see it as, like you were saying, as tools. It's a new tool that we have to adapt to, and I think just discarding it, banning it, not going to help. It's already here. How do we use it to benefit education and benefit the industry? And I think that's something that we're all trying to find out. But I've always seen it as at least from a professional perspective, it's something that we can use to help us out in terms of instead of taking maybe 10 engineers to do one job, maybe it takes half of that because of these tools that we have. It's not going to replace the structural engineer, I don't think, because I still think there's someone that needs to be behind making sure everything makes sense. And obviously the stamp as well in terms of the profession. But I think it is just going to be another tool that we can use to our benefit as a profession.
Exactly.
And I still think it still comes down to behavior. It's not going to know exactly what the behavior is. It's going to be up to the engineer. So I think it's even more important for engineers to know more about the behavior, maybe less about the calcs, the manual calcs, but definitely the behaviors, as you were saying. And as an educator, what approaches do you use to keep your students engaged, especially with complex topics like structural engineering and earthquakes, structural dynamics, form space design? How do you keep them engaged? Like, what are some of the strategies that you use to help teach these complex topics?
I think one of the keys to improve student learning experience is the use of or the effective use of actually the visualizations, animations, software demonstrations to first guess about structural behavior and then show them using the actual calculations or the actual software demonstrations how the structure is behaving. So these kind of small exercises led by the curiosity are the ones which I feel are the most engaging among my students. Another aspect which takes central point in my teaching and learning activities is the development of knowledge products. I feel that all of our efforts will be of little use if we don't convert them into tangible knowledge products for positive changes in society. So I always encourage my students to summarize their ideas or their learning into some sort of knowledge products. All my assessments are also such that they had to summarize their ideas, synthesize their ideas into some sort of short video or a blog like this or similar kind of digital resource. This whole exercise of converting that knowledge, processing it, and converting it into a digital resource provides them a hands-on learning experience and provides them with almost all aspects of experiential learning domain. This is something which I feel is the most interesting part of what I do in my daily courses. So, and again, I would like to emphasize at the heart of all those activities is the understanding of structural behavior, uh, the understanding of what would happen to my structure if this happens. So, I ask them to first guess what would happen and then actually compute it using either manual calculations or software program to confirm their intuition. This is, I feel, is the most interesting and engaging part of all my structural engineering courses.
Yeah, I think definitely that hands-on aspect. I I remember just learning structural dynamics for the first time. Wasn't really too excited about it. I didn't think I was going to be a structural engineer at that point. I was still just taking my fundamentals, and I thought it was pretty boring at first in terms of structural dynamics. Just look at all of these numbers. What are we doing this for? And then it wasn't until I wanted to be, for sure was going to be a structural engineer. And when I retook those classes in earthquake engineering in my master's courses, that's when it was really interesting because that's when we were using these types of programs and we were using building examples. It wasn't just a spring. It was like, okay, this is how we're going to apply structural dynamics to a structural model of a building, something more tangible where you can actually see the results instead of just numbers on a paper. You can see the building deform, you can see it shake. I think that for me, at least as a student, that was a lot more tangible than just looking at a spreadsheet where when you can see the actual building. This is why you're learning these
Exactly.
types of subjects. So I
Exactly.
thought that was really cool. And one thing too, it just reminded me. I don't know if you've ever had because I have some of these Moldo model kits. I don't know if you've ever seen those. They're kind
Yeah,
of like building blocks. Those are
exactly.
cool too.
Yeah, I
Yeah, something
recently came to
tangible.
know about that, and it they seem really interesting. I mean, I think almost all fundamental structural engineering concepts you can explain using them. I would really kind of like to have such kind of a toolkit for my educational resource.
Yeah, those are cool too. I just remember explaining some concepts at work to some of the younger engineers. It's like, oh, there, let's use this. This is how you think something's going to deflect. Similar to instead of just using a computer program, you can feel it. So I think definitely that interaction, something visual, something tangible. Yeah, that's a great way to do that. What about the role? What do the foundational mechanics courses play in developing these core structural engineering concepts and why are they still essential in today's evolving curriculum?
Yeah, I mean, today the role of these foundational courses, they are actually the bedrock of structural engineering. And as I said in the start, that I teach foundational courses in mechanics to first year engineering students. So I sometimes tell them that you will remember me for rest of your lives because I am the first one who introduced the concept of free body diagram or the concept of force equilibrium, the concept of support conditions, the concept which will remain with you for rest of your life. So even when you go to the the actual field, these concepts will be the core or most fundamental around all your practice. So I understand my role or my importance in their lives, being a teacher teaching foundational courses. So since they are the bedrock of structural engineering, I feel that they also hold a whole new room of innovation in how we approach teaching and learning exercise. So, in these courses, although it's just a start for my career in that area, but still I'm thinking of introducing digital knowledge resources or several interactive tools or introducing physical models as you mentioned to demonstrate some of the basic concepts in structural mechanics. I often watch videos of Walter Levin uh, from MIT Open Courseware where he demonstrates several physics concepts in his classes. I sometimes share it with my students and try to develop similar resources to for students to actually have an hands-on practice to experiment to confirm those basic principles. So I think there is a huge potential in bringing innovation in the domain of teaching and learning for foundational level courses.
Yes, yeah, I like how you said, yeah, they'll never forget you since you're teaching them the fundamentals. And it's true. I still remember my statics class and my professor there because I use statics every day at work as a professional. Yeah, we have all these fancy programs, but we still have to go back to statics because,
Exactly.
yeah, how else are you going to learn the behaviors of shears, moments, deflections? That's the fundamentals, and you can't do the finite element analysis by hand. You could, but not practical. You're going to go rely on your basics again to the structural behaviors, and you're teaching them that. So I found that funny. Like, yeah, you're right. You're not going to forget you. Yeah, absolutely. I think that's really cool to see that there's room to improve the education of that. Because I know statics would have been a lot more funner if we had those interactions, maybe some of those physical models or some SAP models, something like that. Because if at the end of the day, it's kind of just numbers, but then once you put that to something tangible, I think it can get a lot more students interested and learn and become more enthusiastic about it. I
Yep,
know that would have worked better out for me as a
exactly.
student.
And there are several simulations or online tools available to reinforce those concepts as well, which can be used effectively as a replacement of having physical models in your class. Obviously, they won't be as effective as having the actual physical model where students can interact with it and experiment and can try them yourself. But uh, I feel that there is a huge potential in using those simulations. There are several computer games which implement concept of statics and dynamics. So while the students are playing those games, uh, they actually are learning how things work in physical world and how things interact, how forces transfer from one load from one object to another. So it reminds me of one group activity which I often give to my dynamic students, first year students, and that activity is around developing digital knowledge products. And one of the product which they can develop is an interactive computer game or a simulation following some concepts they study in that course. So I often receive several interesting computer games which I can play myself to understand how things work, and I often receive several high quality simulations to simulate different natural phenomena. So this is an area which, as I said, has a huge potential to explore different new opportunities in using digital resources to enhance students' learning. And I said that today's students are they heavily depend on animations or interactivity provided by these analysis and design programs to develop their intuition or develop their understanding of the structural behavior. So we as educators have to take up this challenge to more and more effectively use these resources.
Absolutely. And do you mind sharing some of those? Are those available for anyone to like in terms of I think you're mentioning some simulations or games that students could play around with. Are those are those publicly available for us to share or
Not yet. Actually, it was an experiment which I
ah
did as part of my scholarship of teaching and learning activity here at UBCO. So, but now once I have developed a good resource of all those digital knowledge products, I am thinking to develop an online exhibition. But for that, I need to obviously take consent from all the knowledge creators as well as the product developers. But I'm thinking to develop an open digital exhibition to display all those interesting works done by my students over last 2 years.
yeah, that sounds really cool. Yeah, it seems like an innovative way to get students engaged and actually yeah, the visual and animation aspects of it too, which adds a lot of dimension to it. That's awesome.
Exactly.
As we wrap up here, what final piece of advice can you give to structural engineering students or young professionals who want to stay ahead and make a real impact in the field?
My last message would be to always see the bigger picture. Always think that this profession is about people. This profession is about public safety. This profession is about safer communities. Uh, Always there are social aspects associated with engineering problems. So we as an engineers have a tendency to consider environmental aspects or economic aspects, but often we ignore the social aspect of an engineering problem. And in the area of disaster resilience, in the area of earthquake engineering, where I belong, there are many uh, comprehensive social aspects of issues around public safety and around safer community building and so on. So, my final advice would be to always keep that bigger picture in mind. So, whenever you are designing a structure, it's not only that structure, it's the people who will be living in that, it's the community which you are currently building, and you will be part of that community as a designer forever. So, we are not only shaping structures, we are shaping societies, societies of future, societies where our own next generation will be living in. And secondly, I would also say that there is no replacement of fundamental concepts. uh, no matter we have disruptive innovations because of AI, no matter education is completely transforming, but the fundamental concepts, for example, concepts around ductility, concepts around stiffness, deflections, concepts around equilibrium will always remain same. So there is no replacement of developing and working on those concepts. So you should always be investing on those fundamental concepts, regardless of whatever new technologies we are having in our profession.
Well said, Dr. Najam. Yeah, I couldn't agree more. Thank you so much for talking with us today. Uh, I will link your website and your YouTube channel. I think those are great resources for everyone to check out, whether you're a student or a young professional or a professional as well. So definitely appreciate it. And thank you so much for your time.
Thank you, Matt, for your time as well. And I'm really happy to get connected with your audience. And I'm really glad to be here.
Absolutely.
Thank you.
I hope you enjoyed the episode today. We'd love to hear your feedback, comments, and or questions. To leave them, please visit structuralengineeringchannel.com. There you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources or websites mentioned during this episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcasts. Until next time, we wish you the best in all of your structural engineering endeavors.